Okay, so the second section, a little bit different, but it's not like too crazy. Radicals and rational exponents. Okay, so radicals means like that. I mean, a lot of them you probably think of square root, but we're going to talk about third roots and fourth roots and fifth roots. And rational exponents just means fractions. Now, before you freak out, it's not going to be that difficult. Um, so we're basically going to be dealing with converting something that looks like that. And it really means 8 to the 1/2 power. Okay, so we'll get into a little bit more detail in a second. So that means the third root. What times what times what? Like what 3 times? And there's no answer to this. I'm just illustrating because you can't do what times what is 10. There's no answer to that. It's some decimal that's really weird. So this is the same as 10 to the 1/3 power. Okay. And so kind of glancing like. Okay. So you've done like square roots before. What times what is 16? You know, square root of 9, what times what is 3? And so we don't write the number, but really there's a 2. Because what we're saying is, well, 4 times 4 makes 16, so the answer to the whole thing is just 4. Or 3 times 3 is 9, so the answer is just 3. So when we do cube root or third root, what we're saying is what times what times what. A number 3 times, that makes 8. Well, 2 times 2 times 2 makes 8. So then the whole answer would just be 2. Or what times what is 27. Okay, so I mean you could keep going with this third root stuff. So if I did 64, that's 4 times 4 times 4. 4 times 4 is 16. 16 times 4 is 64. I'll give you 2 more. 5 times 5 is 25. Times 5 is 125. So the third root or cubed root of 125 is 5. And the last one is 216, would be 6 times 6 times 6. Are there ones that you might see higher than that? Yeah. I would just memorize these. These are the ones that come up most often. The rest of them, use a calculator. And then don't care. Because if the numbers are really big, I'm using a calculator. So that's totally fine. All right, so how are we going to use this like in some of the problems? So some of them you will, kind of the thing that you want to understand is we have a root here, square root, third root, fourth root, fifth root, sixth root. It just means, if there's a 4 here, that means what times what? Like 4 times. Okay, but the root is the denominator. So like on this last one, we had a 10. So this just stays the same. So if you notice, it's 10 is a 10, 8's an 8. And then on the one like above it, this root was a 3, and it became the denominator in the fraction. So the root is the denominator. Like this one, like it's an 8. So the answer was 2. Or just, it's 3. Okay, so if we had, fifth root of 12, 12 to the 1/5 power. Okay. So some of them you'll just have to convert. So if I had, like from a radical to a fraction or a rational, like exponent like that. Some you'll go the other way. Okay, the denominator is the root. And you don't have to put a 2 for square root. But anything other than a 2, you have to put it. If you didn't put the 2, that's fine. If you put the 2, I think that's fine also, especially with what we're doing. Okay, so you'll have some that your first 4 problems are literally just convert it back and forth. Okay, 2 of them are radicals, make them a fraction. You'll see your answer would look like this one. And then the next 2 are fractions, make them look like radicals. So they'd be like the last 2. All right, then you're going to go into evaluating. Okay, so it wants to know, like, what's the answer? Okay, so here's kind of the weird thing. Like, maybe it's weird, I don't know, depending on your background. But so if you had, let me look at, so we're going to say even roots. So if you had square root, fourth root, sixth root, eighth root, and so on. Okay, no negative numbers. If there's a negative number underneath there, it doesn't work. Okay, but with odd roots, it does work. So if you had a number like that, it's saying like what number times that number makes -8. So you can get a negative with 3 numbers or 5 numbers or 7 numbers and so on. Okay, so it's going to be an odd answer no matter what. So if you go back to, well, now I put -8, so it's -2, but with the third root. Okay, so if I did the third root of -16, or excuse me, of -27, just thinking of the fourth root, that means -3 times -3 times -3 would give me -27. So the answer is -3. And then you can make a negative. Okay, so if it's a even root, 2, 4, 6, 8, 10, 12, whatever, can't do it. Odd root, 3, I don't think you'll have any with 5, maybe 1 with 5. Yeah, there's one of them with 5. You can do those. Okay, so let's see. All right, so you will have some that are going to take some guessing and checking. So it wants to know like what times what times what times what times what, like 5 times to get 243. Okay, so here's the deal to help with the guessing part of it. If the problem is odd, so 243 is an odd number, so odd number equals an odd answer. 1, 3, 5, 7, 9, and so on. Even numbers make an even answer. So in terms of guessing, because if you just said, hey, Mr. Gowdy, what's the 5th root of 243? I'd say, I don't know, let me figure it out. But it's an odd number, and if I have to do it 5 times, the answer is going to be kind of small. So if you think about it, like so some people might go, okay, what about 5? Well, 5 times 5 is 25, and 25 times 5 is 125, and then another times 5, well, 100 times 5 is 500, like it's already too big. So 5 can't be the answer. So it's probably going to be 3. 3 times 3 is 9. So a lot of people like want to just go in order when they multiply stuff like this. And there's nothing wrong with that, but I think it's easier, sometimes anyway. But like 3 times 3 is 9. If I did these 3's, there's no rule that says I can't do those 3's. Well, and then I know that 9 times 9 is 81. And 81 times 3 might be a little bit easier to do than doing it the other way. I don't know. It's personal preference. But that does equal 243. Excuse me, sorry about that. So you will have some where they want you to figure out the answer. And you will have to kind of do some guessing and checking. They might present the answer, or present the problem. Like that last one, they might say 243 to the 1/5 power. Well, I can't do anything with that fraction. I just need to understand that it means the 5th root of 243, and then I can figure out, oh, the answer's 3, like we did on the last one. So you'll have 3 of them where it's already a radical at the beginning, and then 2 of them where you'll have an exponent that's a fraction and you'll need to convert it. So just remember that if you have like a negative number with an even root, you can't do it. And so the answer, what they say, is not a real number. You can technically actually do that using stuff called imaginary numbers, but we're not going to do that in this class. So just for our purposes, if you have any, you don't even have to worry about, is it possible? Oh, it's negative, and that's an even root. Not a real number. Okay, I mean, it's just, don't even like try to start doing anything. Okay, if it's odd, you can do it. If it's even, you can't do it. Okay, and then the last thing you're going to have to do, so we talked about, it's really simple in the last part. We talked about, like what if we had like a 3 and an 8, like that. I don't want to use 8, because you can actually do that one, so it'd be a 2. So I put a 10. Well, what if it had an exponent on the outside? So this would be 10 to the 2/3 power. Okay, if I had Okay, this would be 12. And then the exponent is actually the numerator, and the root is the denominator. Doesn't matter that the 5 is bigger than the 4. Okay, so the exponent goes on top, and the root goes on the bottom. The number stays the same, 10, 10, 12, 12, like whatever. Okay, if you had 3 to the 2/5 power, and you're just going to convert it. So we're going to say, well, the denominator is the root. I don't know why I wrote a 3. I was probably looking at the base. So the 5 goes here. The 3 just stays in there. And then the exponent is like the numerator. Okay, so negative 14 to the 5/7 power. You can throw whatever numbers you want. Negative 14, the root is the denominator, and the numerator is the exponent. Okay, so 8 of your problems is just converting it back and forth. Okay, from a radical to a fraction, or a fraction to a radical. Okay, and then you'll just have 6 problems where you actually have to figure out the number. 13 to 18, you got to figure out the number. Okay, and then we'll worry about tomorrow, or don't have school tomorrow. Tomorrow would be Saturday. On Tuesday, because Monday's a holiday, Tuesday we'll go into like figuring out the actual answers to some of these. Okay? All right. Hopefully that's not too confusing. Have a great weekend. You made it through the first week back. See you next week.